Welcome to Basic Subnetting with IP version 4. In this brief lesson, we will cover reasons to subnet, network addressing, network classes, classless interdomain routing or CIDR, and finally, how to subnet. So what is subnetting? Subnetting can be defined as the practice of dividing a network into two or more smaller networks. So why subnet? 1. Manageability. Subnetting helps you maintain clean separations within an organization's network. For example, you can create boundaries between different departments in your organization, or you could divide the network by device types such as servers and workstations. 2. Security. With logical divisions between subnets, you have greater control over access to various parts of the network. For example, you could restrict those in marketing from accessing files from the Human Resources Department. Subnetting also allows for better containment of security incidents. For example, you may be able to contain a virus outbreak to one department, or you may be able to restrict a hacker from pivoting from one part of the network to another. 3. Performance. Subnetting reduces the amount of broadcast traffic by containing network boundaries at the subnet level instead of sending all broadcasts to the entire network. 4. Flexibility. Subnetting allows the creation of more networks and fewer hosts, or more hosts and fewer networks, depending on whatever best suits your needs. An IP version 4 network address is a unique identifier for each computer on a network. The addresses are 32 bits or 4 bytes. Each of the 4 bytes is called an octet and is separated by what is called dot notation. If you look closely, you'll see the dots. Okay. The value of each octet is between 0 and 255. In decimal notation, the address would look like this. Up at the top, 192.168.1.1. Each IP address contains a network portion and a host portion. The network portion is on the left and is assigned to an entire network. The host portion is on the right and is assigned to an individual host. A host could be a server, laptop, desktop, or so on. In this case, the first 3 octets are used for the network portion of the address, and the last octet is used for the host portion of the address. But this is not always the case. In fact, in some cases, a single IP version 4 address can contain information about the network and its subnetwork, and finally the host. To understand how IP version 4 addresses are divided between the network portion and the host portion, we need to understand network classes. There are 5 network classes: A, B, C, D, and E. But D and E are special cases and will not be considered here. A Type A network uses the first octet for the network address and the rest for the host address. A Class B network uses the first 2 octets for the network portion and the rest for the host portion. A Class C network uses the first 3 octets for the network portion and the rest for the host portion. An IP class can be identified as A, B, or C by looking at the first octet. In fact, we can identify the network class by just looking at the first 3 bits of the octet. In this case, the leftmost bit is a 0. This indicates a Class A network. Note that because the 128 position is zeroed out, the value of the first octet must be between 0 and 127. But because some values are reserved, the first octet in a Class A network must be between 1 and 126. The full IP address displayed here is 64.1.1.1. In this case, we notice that the first two bits in the first octet are 1 and 0 respectively. This indicates a Class B network. In a Class B network, the value of the first octet has to be between 128 and 191. Note that because there is a 1 in the 128 position, the value of the first octet has to be at least 128. And because the 64 position is zeroed out, and 255 minus 64 equals 191, the value of the first octet can be no more than 191. The full IP address displayed here is 128.1.1.1. In this case, we notice that the first two bits in the first octet are 1 and 1 and 0 respectively. This indicates a Class C network. In a Class C network, the value of the first octet has to be between 192 and 223. Note that because there is a 1 in the 128 position and a 1 in the 64 position, and 128 plus 64 equals 92, the value of the first octet has to be at least 192. And because the 32 position is zeroed out, and 255 minus 32 equals 223, the value of the first octet can be no more than 223. The full IP address displayed here is 192.1.1.1. A subnet mask resembles an IP address. It also has 32 bits and 4 octets in dot notation. A subnet mask is used along with the IP address to identify which part of the IP address is used to define the network and which part is used to define the host. The bits in the network portion of the address are masked by using all ones. In this case, since only the first octet is masked, this would indicate a Class A network. In a Class A network, the first octet alone defines the network portion of the address. The rest of the address is used as the host portion of the address. In this next case, the subnet mask includes 2 octets. This is the default for a Class B network. In a Class B network, the left 2 octets are used for the networking portion of the address. The right 2 octets are used for the host portion of the address. Finally, in the last example, we can see that the leftmost 3 octets are masked. Only the rightmost octet is unmasked. This is used as the default for a Class C network. Network addresses and subnet masks are usually written in decimal notation instead of binary. So instead of entering a network address for a Class C network like this, we enter the address and subnet mask like this. An even easier way to specify the address and subnet mask would be to use sitter notation. With sitter notation, we just put a / after the IP address, then specify how many bits are in the mask. For example, a Class C network address and subnet mask would be entered like this. Sitter, or classless interdomain routing, allows us to use a mask other than the default mask used for the network class. Instead of network classes, we can now manually specify the network and host sections of the IP address. This is known as VLSM, or Variable Length Subnet Masking. For example, instead of masking the default 24 bits on a Class C network, we could mask 26 bits. This will change the sitter address and mask notation from this to this. Therefore, the binary representation of the subnet mask would change from this to this. Those 2 bits taken from the host section are what we use to create subnets. This will change the addressing from one network with 254 hosts to 4 networks with 62 hosts each. The reason for this: at first you have 8 bits available for the host addresses. That means 2 to the 8th, or 256 possible addresses. But 2 addresses are reserved, so that would leave 254 possible host addresses. But when you use 2 bits for the subnets, that leaves you 2 to the 6th, or 64 possible addresses. But again, 2 addresses are reserved, so that would leave 62 possible host addresses for each network. That is the end of this brief lesson. I think I at least covered the basics. With that, I will leave you with this quote from Douglas Adams. "We are stuck with technology when what we really want is just stuff that works."